Hello, welcome. So in this tutorial module, we are going to see a very basic fundamental example of using a Verilog, which is a hardware description language, that is an HDL, hardware description language, to describe a hardware, for example, as shown in this figure. And we will wish to implement this hardware in the integrated circuit like this. Okay, we want to implement such circuit, which is a logic circuit in the form of an integrated circuit. So for that, we need to describe your circuit, and to describe that circuit, we use a special language which is called as hardware description language, and specifically we are talking about the Verilog. So there are few constructs that we used in Verilog to define and describe our hardware. So first thing first, we understand what is our hardware. So this is your complete circuit, as you can see that. And in this circuit, I see I have got A, B, and C are the input variables. And output of this circuit is E. So I can also understand this circuit like this. You can see that this is in the box. In the box, I have these circuit, and I have got the inputs A, B, and C, and the output is C. There is one internal output also, or internal connection, where I see that I have named that internal connection as D. Okay, but final output is only one, which is E, and the inputs are A, B, and C. So what I see here, there are two gates. So one is the OR gate and one is an AND gate. And I want to implement this circuit in the form of an IC, so that the circuit goes inside this ICs, and when I want to use them in my system design, I can use that IC, which will have inside this particular circuit. So I see that the OR gate has two inputs, A and B, and output of this OR gate is D, and then D becomes an input to this next gate, which is AND gate, and C is also coming as an input to this AND gate. And finally, I have this E as the final output. Okay, now if I ask you to write the Boolean expression, so there are this expression I can write: D is equal to A or B, and then I have E that is equal to D and C. And I can see that D is actually A or B and C. So that's my final output. E is equal to A or B and C. And this is what I want to implement in form of hardware. I want to implement this hardware. So what I do usually in the Verilog, you always start with module, and then you end with end module. These are the two operators or the constructs that you will remember. In Verilog, always start with module and then end module. Now, you, after the module, give name of your circuit. Let's say simple circuit is the name of my module. Or I can simply say, let me call it, for example, my circuit. My circuit. Okay, you can have a space in between these one, but you cannot have space in the single operator right here. Okay, so okay, my underscore circuit can also be written as. So here you see that I have used the name as a simple circuit, and here I am giving it as a my circuit. So you can choose any name like that. When you are done with that, next task is to define your line in the parenthesis. In the parenthesis, between the parenthesis, you have to define your inputs and outputs of your circuit. And after the parenthesis, you end the parenthesis with the semicolon. Okay, So here exactly what I have done. You see that module, the name of my simple circuit, name of the circuit is simple circuit. Then I have used two parentheses and then semicolon. And then in between the two parentheses, I have to define output and input of my circuit. So what are the output? Output is only one because D is the internal connection. So output, final output is E, and the inputs are A, B, and C. So that is what I want to do it here. So I will write here the output E is E, and then comma, and then input is A comma B comma C, and then bracket close. So now you note here that the module output input, these are the these are the Verilog constructs. So these are always in the bold letters. When you will write this code in the EDA using the tool, you will see that these will come in the bolds, and this will be the simple one. So the output is my E, and A, B, C are the inputs. Now I have to write one more sentence, that is the wire. Why? Because there is an internal connection D, which is then connecting to the AND gate right over here, and C is coming right here. So I will say that, okay, I have the wire here, which is the D, and again I have to end the statement. Every statement will end with semicolon, and that's what precisely I have done here. Look at this wire D semicolon. Now I have defined the inputs and outputs. I have defined the wire, that is internal connection. Now I have to actually tell the tool, which whenever I will use a tool or software to write this code, I have to tell the tool what operation it needs to perform. So operation first is OR and then the AND. So I am assigning the ORing of A and B two variables. These are the two variables, and ORing of these two variables I am assigning to another variable called D. Similarly, I am assigning ANDing operation of these two variables D and C to the variable E. So that's why I will write here the two construct, and these are also in bold, assign. You can see that. So D is equal to A or B semicolon. After this end of the statement, don't forget to use semicolon. And again, I will say assign E is equal to C and D. Now, if you see that there is this spatial operator I am using, this operation is called as used for performing the OR operation, and this operator is used to perform the AND operation. So that's what precisely I have done. Assign D is equal to A or B, and assign E equals to C and D. So this operator again represent the ORing. This operator again represents the ANDing operation. Finally, you have the end module. You started with the module and you end with the end module. So that's what you actually have it here. That's what you actually have it here. So this is all for the very first example of using Verilog in so that's the hardware description language, and you are describing a hardware. This is a simple combinational circuit. Let me write here. This is your combinational circuit with two input OR and two input AND. And this circuit you want to implement in the form of integrated circuit. So for example, this is a board on which there are ICs, and inside the ICs there are digital circuits that have been implemented by writing first the Verilog description, the Verilog constructs, which are basically the describing your hardware, and you are defining input and outputs. Then you are assigning the logical operations. You are defining the internal wire. You always start with the module and the end module. So hope you found this module useful. If you did so, share it with others for wider reach and stay tuned for more engaging content like this. Till then, wish you happy learning.